So can can everybody hear me? Okay. So last talk for this evening. I think officially I have about 20 minutes left. Oh, let's see. Yeah, about 20 minutes. So who of you is using IPv6 already? Oh, that's a lot. That's okay. 5 people. Who is planning to use IPv6 in the near future? Ah, that's better. So this is not an IPv6 introduction, as a warning. This talk might contain some humor, irony, and some nerd jokes. Somebody complained about that in my last talk, and I'll just give out a warning here. And these are guidelines, not strict rules. So this talk might not scale for you to either end. Either you're very, very big, and it will not scale, or you're a 3-people company. So IPv6 has a chicken and egg problem. Which one is first? On the one side, we have content providers, and they don't offer any content over IPv6 because there are very few access providers. On the other hand, there are access providers who don't offer IPv6 access because there's no content. I did several talks on IPv6 in the last years, and I collected some quotes. We'll introduce IPv6 in 14 years. It's when my colleague will retire. IPv6 is not an interesting topic. Everybody knows everything about it already. Who of you does know everything about IPv6? No hands up? Even I wouldn't raise my hand. And this one was my favorite from 2 or 3 weeks ago. When will IPv6 be as secure as IPv4? This was 2 or 3 days after Cisco announced a vulnerability in their firewall service blade, which only was IPv4. So there is no big red button which somebody will press and IPv4 will cease to exist and there will only be IPv6. Well, that's not entirely true. The US Department of Defense has a big red button, and they have a big screen with a lot of green and red dots, and for every service they migrate to IPv6, 1 dot turns from red to green, and when the screen is completely green, they will press a big button and stop using IPv4. That's a rumor. IPv4 and IPv6 will have to run in parallel for quite some time. But some resources will be available only by IPv6 in the near future, hopefully. Freddy tomorrow showed you the counter with 706 days. Last week it was 686. So it's around about 780. And there's no need to change everything at once. So take your time, you still have it. And some parts of the network will still be running IPv6 for the next couple of years or decades. So I have a laser printer at home with network access, and it's working fine and doesn't run IPv6, and there is no need for me to change it. Just because I need to print over IPv6. I've stolen this first part from Google. IPv6 is not rocket science, but there are some differences to IPv4. And it's now time to talk to your management and demand time, because in the long run it's cheaper to start now. But I'm happy to support you in a year or two. I'm a freelance consultant, so I already calculated my rate for this time. Ooh, we need IPv6 yesterday. set up a test environment and learn. Virtualization makes it easy, but virtualization doesn't help with everything. If you have some special Cisco or Juniper hardware, you can virtualize iOS in Dynamics. Does anybody not know Dynamics? Okay. But you can't emulate special line cards you put in there, which might have problems with IPv6. Train your staff, and this is really, really important. Train your first level support. This is also the reason several German companies don't offer IPv6 officially already. They have some really good Unix people running their servers. They have some really good network people knowing IPv6, running IPv6. But there are several customers who would be really, really confused to find IPv6 on their servers suddenly running, and they talk to the help desk first. These are companies where they rent game servers, and some of the customers send them graphics cards. So please put this graphic card into my server so I can run this game. Or, yeah, I've rented a root server. You gave me the password, but what's the username? Yeah. Then check your hardware, switches, routers, printers, etc., if they support IPv6. And when you buy new hardware, make sure it can run IPv6. There is an American Department of Defense standard profile how they define IPv6 compatible. So the slides will be online. Just click on there and you get a PDF about 300 pages what they consider this product is IPv6 compliant or not. Yeah. After that, you should make a plan, IP addressing, which protocols to use, a budget for new hardware. Then you should check your hardware and software again, because there might be IPv6 support, but there's just one feature you might want to use, but which is not there. About 2 years ago, Cisco 6500 fully supported IPv6, except DHCP relay for IPv6 and OSPF authentication. 2 features that were necessary in the setup. Yeah. Then you should configure your internet access, make IPv6 available on your internal networks, including address configuration, routing, and so on. And then deploy IPv6 services. I'd recommend to start with DNS. Makes IPv6 a whole lot easier. If you need DHCP for IPv6, you should configure DHCP for IPv6. There is stateless auto-configuration, but there are some problems with additional values like NTP servers. You don't get them over auto-configuration. And also DNS is a problem. And then change services which require no user interaction, SMTP. A user uses his mail client to write an email. He clicks send, and what the mail server does in the background doesn't concern the user. And most people think that email is a real-time media, so you click send and the other end should have the email, but that's not entirely true. T-Online in Germany had some problems with some spam relays in their network, and they had some really, really serious delivery problems with emails just last week. And be careful when offering IPv6 services to the outside. There are some broken networks out there. So some administrator configured a tunnel and it's leading to nowhere, and the client gets IPv6, but the IPv6 address doesn't get routed outside. There's an RFC that states that IPv6 addresses should be preferred over IPv4. So the browser selects the IPv6 address and user runs into a timeout. I was told by Google that this is one of the reasons they don't offer they don't have a quad A record for a www.google.com. You only get a quad A record from Google if you ask them kindly to put your DNS resolvers in a separate view on their DNS server. Yeah, and then be prepared to see strange errors. And while you learn and experiment, learn to troubleshoot. And there will be some errors that have nothing to do with IPv6. They will magically occur when you start IPv6 in your network. I was at a customer a couple of weeks ago. They had some really, really strange problems because they migrated an FTP server from one operating system to another operating system. And the developers of an application who used this FTP server, since you changed the server, nothing is working anymore. Well, the application wasn't running before. They just blamed the new operating system. And same will happen with IPv6. So you're starting IPv6 on the database server, the hard drive runs full, and it's certainly IPv6 problem. Then there are some problems. Some older hardware might not support IPv6 hardware. There might even some newer hardware that doesn't support IPv6. A friend of mine who wrote the RFC for IPv6 over ArcNet has a voice over IP phone on his desk, and it doesn't support multicast and therefore doesn't support IPv6. Brand new phone. Then there is, for access providers, the problem of CPEs, the little router that sits at the customer at home. There is AVM. There are the small Cisco boxes, and then there are these Linksys WRT routers with a not official firmware that support IPv6, but others, I don't know. Somebody from D-Link here? They have booth out there. Maybe they support it, I don't know. And then there are appliances. Every CEO, CIO loves them, so you put a box in your rack and yeah, it's all pretty configured in a nice web interface, and we don't have to take care of the operating system. But there are some problems with them and IPv6, especially if you use some of these spam filtering appliances. Still looking for commercial spam filter appliances that support IPv6. Some software you are using might not support IPv6, like Apache 1.3, Squid before version 3.1. When I first prepared a talk on IPv6, said Squid 3 will support IPv6. And my second talk, Squid 3, was released 2 or 3 days earlier, and we will support IPv6 in version 3.1, and now they support it. And what about commercial software? And I'm not talking about Windows, because Microsoft is a really, really great supporter of IPv6, except in their firewall. Microsoft Ether server doesn't support IPv6 right now, which surely states, and Microsoft tells you we are using IPv6, this also tells you that they can't use their own firewall product. What about custom applications? Something somebody wrote years ago in your company, he's long gone, and you still have this small database application or whatsoever. I've been to a customer last year, and he still was running Novell servers with IPX for his bookkeeping, and he had some serious troubles with modern Windows clients. So these are still there. And then there is the problems of firewalls. Some firewalls are not aware of IPv6. The good thing is, some drop IPv6 completely. The bad thing is, some pass it through without even noticing that traffic is going through the firewall, which is nice. And there is no real standard for real-time blacklist for spam filtering. Okay, questions so far? Okay, when doing IPv6 address planning, forget everything you know about IPv4. But don't forget IPv4 completely, because you will have to deal with IPv4 for a couple of years. Be generous. It's normally said that /64 is the smallest network size. There are some problems and some implementations which will complain if you use a smaller network. I have one server with /112, and it works, but it complains on the log file. Nobody can explain to me what this message means. Aggregation is important. The routing table, the global routing table, should be as small as possible, and so should your internal routing table. A couple of weeks, I think 3 weeks ago, we cracked the 300,000 routes in BGP. There is RFC 5375, which gives you some hints on address planning. And with some thinking, you can code interface IDs and connections and VLAN inside your interface address. So you can easily see in a trace that it's going from this router to this router to this router out to this interconnection. You just have to think a little bit about it. There are several methods for assigning addresses: static configuration, stateless auto-configuration, and DHCP. DHCP v6 does not assign addresses according to the MAC address of a host per default. You can do a little scripting, but per default it doesn't work. And I would recommend that you use static configuration for routers and servers, and stateless auto-configuration or DHCP v6 for clients in your network. You might even want, if you rent a lot of servers, you might even want to use DHCP v6 instead of stateless auto-configurations for those servers, because customers are stupid, and if you change the hardware with stateless auto-configuration, the server will get a new IPv6 address, the user has to change his DNS and his firewall routes, and so DHCP with some scripting to bind to the MAC address should be considered if you have lots and lots of servers and lots of stupid customers. So, and if you're an access provider, RFC 3177 suggests at least a /32 for a normal layer. And at least and a /48 per customer side. /48 are about 65,000 /64 networks. So that should be enough. German Telecom has a /19s network. But for normal sized ISPs, this should be enough. And RIPE says that a minimum size of /64 should be assigned if only one network is expected. A friend of mine asked his provider if he offers IPv6. The answer was yes. And he asked for a /48. And he got the answer from sales, well, you can have 4 addresses for just 25 euros a month more. Yep. The rate they sell IPv4 addresses, so they didn't understand it quite. Internal addressing, use one of your many networks if you have a /32 for loopbacks. Use one /84 for point-to-point links. And maybe you should use the first network for doing some internal servers if DNS dies, so you can remember this address. So my DNS server is 2001 DB8 : 1, something like that. IP address assignment to customers, configure a transfer LAN and route a network to the customer. Here are some people are complaining about this, at least in Germany, because they then will have static IP addresses, and Google knows when they visit their site, and this other e-commerce site can see who connected to their site, and there is also the possibility to use DHCP prefix deployment to dynamically assign IPv6 networks to a customer router, like it's done today. So every time you reboot your small home router, you get a new IPv6 network at home. It's a small problem for the customer. If he uses more networks internally, he has some problems with renumbering when he gets a new network. But that's the customer fault. He can also use static configuration. Yeah, we had firewalls before. Most firewalls support IPv6 to some degree. There might be some filters missing, especially if you look in the extended headers of IPv6. There are some people out there who claim that ICMP is a big security risk, and if somebody can ping my laptop or my host, then I'm at risk. IPv6 needs ICMP, and completely dropping ICMP with IPv6 will result in a very, very secure network. You won't even have layer 2 communication. There is another RFC 4890 which describes which ICMP-v6 types to filter and where to filter and how to filter. And there is another big drawback on IPv6, or one reason why people don't deploy IPv6. There is no network address translation for IPv6. Network address translation is confused by some people with security. There is something like NAT for IPv6, but it's not like IPv4. It's just one-to-one. Address A is translated into address B. But I'm sure there will be something like PAT for IPv4 for IPv6 in the future, because people want it. And RFC 4864 describes some alternatives to NAT. Just read it. They also explain why NAT is not a security feature. Yeah, some filters might be missing. There are some vendors who don't support IPv6 access lists, so either talk to your vendor to support IPv6 access lists, or use IPv4 for management because you have access lists there, or think of something else. I know that Nokia, with the Nokia checkpoint appliances, they don't support IPv6 access lists in IPv6.star. There are some features like, or equivalents for features like DHCP snooping missing. There are working groups on that. So, and now to the interesting part, with nothing really new, routing. We have for IPv4 RIP, for IPv6 RIP NG. We still have IGRP, we have OSS, we have ISIS, and now the standard question, who of you is using ISIS? Who of you knows ISIS? Ooh, okay. And BGP. For external routing protocols, the choice is clear, BGP. For internal routing protocols, keep it simple, stupid. Which protocol do you know? What are you using for IPv4? And my guess would be that there are more people knowing OSPF and knowing how to troubleshoot OSPF problems than people knowing ISIS and troubleshooting ISIS problems. And if you want to be stuck to one vendor, or do you want to use an open standard? IGRP is a nice routing protocol, but you're stuck to Cisco and maybe some older Nokia boxes. They really have this feature in their firewall to use IGRP. I've never tried it. They want an extra license for that. And this is a chance to document and clean up your network. Consider IPv6 as chance. So the static route there you configured a long time ago, or your colleague configured a long time ago, and nobody knows what it's doing. or this firewall route, this is a good reason to clean up and document. And this is the most important part. Before you start implementing IPv6, you should have a proper documentation. I know you will hate me for this. Yep, and this is my growing collection of things not to do. There are actually some DNS administration tools who do this, who sees the problem. So you have your A record for IPv4 and you have a quad A record for IPv6. This here on my t-shirt is localhost. So you point your customer to your real web server, and if he's using IPv6, you point him to his own server, or to his own workstation. And if he has running a web server there, he might find all the video and music very boring because he already knows it. Okay. Yeah, I hurried a little, so we can already go to the party. Here are some books if you want some further reading. There's a book from a friend of mine, Benedict Stockebrand, IPv6 in Practice. It's a little bit older, but it covers the Unix side, namely Linux, FreeBSD, and Solaris. Are two books from Cisco Press, they fit together. The security book is referring to the other book, so you should read both. There was a conference by the German Unix user group called European Conference on Applied IPv6 in 2007 with the proceedings. There are some texts about IPv6 there. There's also a website, and also this here is German. All slides are in English, including some slides on how to put IPv6 in your Windows network and stuff like that. And then there is the DoD standard I mentioned before, and this down here, I will translate it to English. The American National Security Agency, or no such agency, has also something to say about IPv6 firewalling. So, any questions? No? You are? Yes? Well, this counter is running down, and sooner or later you should start, and I prefer to learn things slowly and over time, and yeah, if you start when it's too late, you probably will make many mistakes and spend a lot of money.
I understand, but maybe different question. Because as I know, most of solutions for IPv6 to IPv4 and the opposite way have serious issues. So what about this? This is not efficient, and we are afraid about using this since this is not efficient.
For HTTP, if you have a normal office, you can use HTTP proxy. Works very good. For SMTP, there is no solution needed. You just need a mail server like Postfix SendMail that supports both protocols. Then there is a NetPT, which was mentioned in Freddy's talk this morning, which is deprecated by now. Cisco still supports it, but it's deprecated, and there is work in progress on a successor for that. But you can run IPv6 and IPv4 in parallel without any problem, and you don't need necessarily to translate between them. That's a good question. I don't know.
Linux virtual server. As
Linux
far as I
virtual
know,
server
it wasn't supported quite a time
should
ago.
support IPv6 by now.
Okay, I might not be very up to date.
I talked to a friend of mine a couple of months ago who uses Linux virtual server, and he said that it is supporting IPv6 right now.
Okay, so I'll contact you.
As is Firewall Builder and all the other Linux tools. And
okay, thank you.
the only thing that doesn't there's two things in Linux that don't support IPv6. The one is the standard syslog daemon, and NFS port mapper doesn't work with IPv6. There's a website by Peter Bieringer, deepspace6.net, which lists a lot of Linux and Unix applications and their status for IPv6 support.
One more question. Don't you think that operators maybe may prefer using standard NAT still instead using IPv6 and all troubles connected with this DNS proxy, SMTP proxy, and so on? Because it's quite complicated right now to make the hybrid network.
Not really.
NAT can be simpler still.
No. Ever try to troubleshoot double NAT or triple NAT or more than single NAT? So we have 10.8 here, you have something here, and you have 10.8 here, and you NAT more than one time in between, you get crazy if you have to troubleshoot a problem there. And I was told to refer to the developers of maps.google.com. If you want to get killed, tell them that NAT is a great idea. So they use many connections in parallel. And if you have several users who using maps.google.com and well, many sessions in parallel, it might kill such a Soho router because there are too many TCP connections being netted. And there are some applications where about 2/3 of the code are used through traversing NAT and to fight against NAT to work for the end user, and you could save about 2/3 of the code just by using IPv6. There is one problem in the applications that are torrent tracker. I was told that Pirate Bay had some issues with IPv6 because they suddenly needed much more memory to keep all the IPv6 addresses in memory. So, any more questions?
I've got a question. Do you know what's the current status of provider-independent addresses in IPv6? Because some people insist that they want to have a private independent allocations.
Since March or May? Yeah. End of March.
All right. Thanks.
No more questions? Then let's go to the party.
Dziękujemy raz jeszcze i przypominam, że o godzinie 19:30 spod budynku głównego będą podstawione autokary, które zawiozą Państwa do klubu Lizard King na ulicy Świętego Tomasza. Dziękujemy bardzo.